In earlier chapters, we have written pseudocodes that perform any operation only once. In a real-life situation, you will often need to perform the same steps many times. For example, if we are calculating the percentage of students, there will always be more than one student. In such situations, we need to repeat the same calculation many times. This is called an iteration. This chapter looks at the techniques in iteration. Iteration constructs are used when you need to perform the same set of operations more than once. For example, adding 2 to a variable x 3 times. If we have to write this without iteration construct, the sequence would look like this. X is equal to x plus 2, x is equal to x plus 2, and x is equal to x plus 2. Imagine the length of the code if you had to add the same 1,000 times. The same set of operations can be represented using an iteration construct in a simple and elegant way. Iteration constructs are also popularly called as loops. Here, 3 types of loop constructs are discussed, such as while loops, repeat loops, and for loops. Each type of construct has some specific characteristics. Single statements or groups of statements, called compound statements, may need to be executed a number of times in a program. In some circumstances, the number of times a single or compound statement has to be repeated is predetermined. In other cases, statements must continue repeating until a certain condition has been met. Consider a case when you have to print 5 address labels. It is tedious and inefficient to code the printing instructions 5 times. Usage of the for loop is appropriate if the exact number of iterations are known. Let us look at the syntax of the for loop. Now let us see how the for loop works. Initially, it assigns the start value to the variable where. Then it checks whether where is less than or equal to end value. If it is within this range, the embedded statements are executed, and the for loop automatically increments the value of var and moves on to the next iteration. If the value of where exceeds end value, the loop terminates. Using loops eliminates repeating statements, resulting in shorter and more readable code. For loops execute statements inside the loop a set number of times. Each cycle in a loop is called an iteration. The variable where is called the loop index. The loop will repeat as long as the loop index remains smaller than or equal to the upper limit. As soon as the counter exceeds the upper limit, the loop will stop executing. Programs can be written that allow a user to specify the number of times a for loop will be executed during the running of the program. In this case, the user is prompted for a number that will be used as the upper value of the loop index. Let us suppose that you need to write a program to print 5 address labels. Once your details have been input, statements to print the labels must be executed. It is not necessary to code each statement the same number of times that it is required to execute. In this example, a for loop is used to print 5 labels. Your details are input. A loop is created using a loop index called count, which starts with the value of 1. Each time the loop is executed, count is incremented by 1. This is the default increment in a for loop. When count exceeds 5, the loop is terminated. Suppose you want to write a program that calculates the total mass of the cargo in a container. The number of parcels in the container is unspecified as yet. You list the number of packages in each container and the mass of each package as input elements in the defining table. The total mass is listed as output. Processing tasks include calculating the total mass of all the packages. You start writing the algorithm by asking for the number of packages in the container. A for loop will be used to get the weight of each package and add it to the total. Since a value for mass must be captured for each package, you set the upper value of the for loop to the number of packages. The statements in the loop get the mass of each package and add it to the total mass. The loop will execute as many times as there are packages as determined by the user input. Here is one example of for loop. Upon execution, it will result in the output 13579. The default step is an increment of 1, but you can change it by adding the step keyword after the end underscore value in the for statement and specifying the size of the step, 2 in this case. The control variable can be decremented rather than incremented by using down 2 instead of 2 as is shown here. This code results in the output 1098765431. Check out the code given below. The output will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. In the for loop we saw that the value of the variable count is incremented by 1 every time the loop is executed. This is automatically done and is called the default increment value. If you want to increase this increment value, it can be done using step clause. Say for example, you want to increment the variable each time by 2, then the pseudocode should be modified as follows. Here, the value of count is initialized to 1, and in the subsequent iterations, this value is incremented by 2. This means that the value of count would be 1, 3, 5, 7, 9. Once it becomes 11, the loop terminates as the value is greater than 10. The properties of for loop are, the loop exits after a specific number of iterations depending on the beginning value and the increment value. Loop exits when loop counter exceeds the end value. Loop is pre-tested. This code calculates the sum of the first 5 integers using the for construct. A line of code cannot be written each time a criterion is to be tested. This is because sometimes the programmer cannot know in advance how many times the user will require the criterion to be tested. The solution to this problem is to use the while loop. While is the keyword that tells us the type of loop. The condition within a while statement tells us that the statements within the while loop shall be executed until the stated condition remains true. A while loop executes a statement or compound statements while the loop condition is true. As soon as the loop condition becomes false, the loop terminates. The while statement is an entry condition loop. This means that the program checks to see if a condition is met before passing through the loop. In a situation where the condition is immediately false, the loop will not be executed at all. A while loop will continue to run indefinitely unless the loop condition becomes false. The while loop must therefore include a statement that changes the conditional expression. When the loop condition becomes false, the loop terminates and the program continues by executing the statements following the loop. The statements that belong to the while loop are written in between the do and do keywords. The group of statements within the scope of a loop is called the body of the loop. This is a construct that executes a set of statements as long as the specified condition persists. The syntax of the while loop is as shown here. Let us suppose that you have to write an algorithm to print one or more labels. Here is an algorithm that will capture the user input, print a label, and then ask the user whether another label is required. In this section of pseudocode, the loop condition is answer is equal to yes. As long as this condition is true, the loop will continue to execute. Before the while statement, the variable answer is set to yes. Because the loop condition answer is equal to yes is true, the while loop is entered and a value is printed. The user is asked whether to print another number, and if only one label is required, the answer will be no. The loop condition is tested again and found to be false, so the program continues execution after the while loop. If the user answers yes to print another number, the loop will repeat. While loops have a different syntax in each programming language. We shall now write a pseudocode using the while loop to accumulate 2 1000 times. Incidentally, times is a variable that is commonly known as a counter because it performs the function of counting the number of times the loop is processed. In the above example, when the keyword while is encountered, the condition given with it is checked, that is, whether times is less than or equal to 1000. Depending on the result of this condition, the loop will or will not be executed. The first time, times is equal to 1, so the check proves to be true, the two statements within the do and do construct are executed. When end-do is encountered, the control of the algorithm is transferred back to the while statement and the condition is checked once again. This iteration will continue 1,000 times. In the 1,000th time, when 1 is added to times, its value becomes 1,001. The control is then transferred back to the while statement, and when the check is performed, it evaluates to false, as 1001 is neither less than nor equal to 1000. Let us see how to write a C code using while loops to find the sum of 10 natural numbers. Here we are placing two variables, both integers, for numbers and sum. Number is initialized to 1 because it is the first natural number. Sum is initialized to 0. While being a pre-tested loop, the value of num, which is less than 1, is tested first, and the statements belonging to the while statements are executed. Inside the while loop, number is incremented by 1. When the value of num exceeds 10, the loop is terminated. The sum is displayed using the printf statements. Enter the loop from one location. A variety of loop control structures allows you to test at the beginning, middle, or end of a loop. These structures are rich enough to allow you to enter the loop from the top every time. You don't need to enter at multiple locations. Put the initialization code directly before the loop. The principle of proximity advocates putting related statements together. If related statements are strewn across the routine, it is easy to overlook them during modification. If related statements are kept together, it is easier to avoid errors during modification. Keep loop initialization statements with the loop they are related to. If you don't, you're more likely to cause errors when you generalize the loop into a bigger loop and forget to modify the initialization code. Assure yourself that the loop ends. This is fundamental. Mentally simulate the execution of the loop until you are confident that in all circumstances it ends. Evaluate all the possible cases that could arise. A loop that never ends is called an infinite loop. Make loop termination conditions obvious. If you use a for loop and don't fool around with the loop index, the termination condition will be obvious. Likewise, if you use a while loop and put all the control in the while clause, the termination condition will be obvious. The key is putting the control in one place. Let us suppose that you are receiving cash donations for a charity. You would like to print a receipt for each donation. After all donations have been received, you want to calculate the number of donations, the average donation, and the total donation. The elements of a problem are broken down into inputs, outputs, and processing tasks in a defining diagram or table. Nouns in the problem statement are usually inputs and outputs, while verbs can indicate processing tasks. The amount of each donation belongs in the input column. Receipt, number of donations, total donation, and average donation are placed in the output column. The first processing task involves getting the amount of the donation. Then a receipt is printed. The number of donations, total amount donated, and the average donation have to be calculated and displayed. These tasks are entered in the processing column. You use the defining table to write an algorithm to execute the task. The algorithm begins by declaring and initializing the necessary variables. Within the loop, the user is prompted for the donation amount. A receipt is then printed for that amount. This amount is added to the total amount. Next, the variable count is incremented to indicate the count of the number of donations that have been received. You will be asked whether there are any further donations to be accepted. If the response is yes, the loop will be executed again. Otherwise, the while loop will be terminated and control will pass to the first statement outside the loop. The compound statement inside the loop gets each donation amount, prints a receipt, adds each amount to the total amount donated, and increases the total number of donations by 1. When the loop terminates, the average donation is calculated. Finally, the number of donations, average donation, and the total amount donated are displayed.